Everyone, welcome back to another lecture on the course Python Fundamentals Building Blocks for Aspiring Developers. We will continue with the sixth module that is about file handling. So, according to our agenda, we made a little change, and this time around, we will be working on error handling and exceptions, file handling in operation. So, let's begin. So, first, we need to understand what error handling is in Python. So whenever we are writing some code, you must have encountered loads of errors. You might write incorrect string or incorrect syntax or things like that. So what error handling does is that it allows us to handle those errors. So it is essential, it is good to know because we can handle those errors in a much better way. Like we can still keep the code running if there is an error. Whereas if you don't handle the error properly, if the error arises, um, Python will stop the execution of the code and you will have to run the code again. But in some cases, you might want to keep running the code. If the error is there, you might want to skip the part or maybe make some other changes, but you keep want to run the code. So this is why we need to handle the errors in a better way, gracefully, so we can do it like this. So errors can occur in different types. They can occur during file operations, like we want to update a file, we want to read a file, the file path is incorrect, things like that. So all these sort of errors. So Python basically provides functionality for us to do that, and it makes it pretty easy for us. So again, it stops the program from crashing and stopping, and instead just raises the error and moves on with the code. So there are these three types of errors that we mostly encounter. Um, Syntax error is raised when the Python interpreter encounters a syntax error, like we put something incorrect. The syntax error, maybe we miss a semicolon or things like that. File not found error is when we are trying to access a file. Um, Maybe we have incorrect path, maybe we have an incorrect extension or things like that. Then type error is raised when an operation or function is applied to an object of inappropriate type. Like for example, um, add I cannot use a plus operator between a string and a number because they both cannot be added. So those type of errors are type errors. There are a lot of other errors possible. You can have a look. For example, we can also have a zero division error. That is, if we divide a number by zero, it it cannot be solved. It is undefined. So we have this error. Then we have a value error, things like that. We can have all sort of errors. But what we are interested in right now is in the context of file handling. So here we will have a look at one of the examples. Um, so here on the right, you can see a code which is trying to open a text file as in a read mode, and then there are a lot of exceptions. So you can see that we can also have multiple exceptions um, in one try except block. So what happens is that we if we go to the syntax at the bottom, you can see that we have try and except. So what happens is that whatever the code we want to do, we put it in the try code block. Like we want to do an operation, open a file or something like that, we put it there, and then we have this except, and we can mention the exception type. For example, we mentioned zero division error over there. So in the try statement, we're trying to take an input from the user and then trying to divide the 10 with that number from the user. And then we have an except. So if the error is raised, like if we do the result is equals to 10 is equal 10 over number, if an error is raised in anything within the try block, then it raises an error, and then we can catch the error. Like if it raises a zero division error, it will go in this part of the except statement. It will say, okay, now I will print this. If it raises a value error, it will go in this part and not go in this part. So similarly, if we have it here, it will start with this one, try and execute this code. then based on the error it will go either here or either here. But if the error is something different from these two, like we do not know the specific type of error but we still want to catch it, we can use this syntax. We can use class exception as e. So exception will catch all the errors, even these ones, but we have specified these ones specifically. Any other errors other than these ones will be caught here, and we say as e. So it is just like as e, just store the error in this variable e. So it's like this. Then we can print the error. And we can also have an else statement, that is, if the exceptions do not occur, then we have an else statement, or this try works, no exception, we have else, and then we have the finally keyword. So anything that is in the finally keyword is in the finally block will be executed irrespective of if the error was raised or not. So if we go down, we say the Python executes the code, then the exception occurs. If the exception occurs, it raises that exception and goes to that piece of code. So the program jumps to the except block that matches the type of exception raised. Then the code inside of the except block is executed to handle the exception. It could be very simple code, it could be a difficult code, it depends on the use case that we have. Then if no exception occurs in the try block, the except block is skipped and the program continues to execute normally. So let's start coding. So I will go back to the Python file. So I already have this over here, one of these examples. So just remove everything from previous one. I will save the file, still module 6. Okay. Let's close previous ones for now. Yeah. So first, let's try and understand the try and accept. So let's say I have this try. Here I'm going to write something. I will say number is equals to, like, whatever operation I'm going to write. Like I would say print whatever I want to print, and then in the except key block I'm going to write the exception or something else. Then I can also write the finally keyword. Okay, so I've written all of this here. So what I've done is that I'm taking an input from the user. So the user can enter a number, right? So if the user does not enter a number, there could be a value error. Like if I try to enter maybe some alphabet instead of a number, there could be an error. And another error that I encounter is the zero division error. If user enters 0, then 10 divided by 0 is an error. We can check this one quickly. Like if I just comment this out, I want to show you that 10 divided by 0 is an error. So if I do print this, I'm just dividing 10 by 0. Let me just exclude this one and run the code. So it says zero division error. This part gives zero division error. So I can copy this from here. Okay, this is the error that I have. I can paste it here. It's the same exact thing. And then if I do move this, and now instead of the zero division error, what it will do is that it will execute this piece of code over here. So let's see how it does. So I will save the file, run the code. It asks me for an input. I will say okay, 0. It says error cannot divide by 0. It did not show me like this, like error this and this. It just said error cannot divide by 0, whatever I wrote in this code. What I could do is that, let's say if the user has entered 0, what I want to do is that I would say num is equals to 1 and result is equals to 10 divided by num. Then I can say print I changed the number to 1 because it was 0, and this is the result, right? And then I can put in the result over here. See how it goes, run the code. So if I put the number 0, it says okay, I changed the number to 1 because it was 0 and this is the result. So whatever I put in here will be executed. Now if I put in the correct number, like if it's not a zero division error, I say 1, or I say let's say 4, no error, right? So here we can say finally print, let's say result is 0 initially, okay? And we say finally print your final result is what is result, okay? Yeah, so I run the code, I put 0, it says the final result is 10, it is still executed even with the error. Now if I try and do it without an error number, it still says your final result is this one, because this finally keyword will always be executed. Now let's try and see if you can get a value error. So instead of a number, I will write F. So it says error, please enter a valid number. This one, because it was a value error, right? Now if I, instead of this, I say accept exception as E. I do not, I only am catching the zero division error, and any other error I want to do it like this. So instead of this, I say print error occurred. What is the error? Error is E. So E is like the variable in which the error is saved. So I run the code. I open something else, and it says invalid error occurred, invalid literal for int. So it simply means that it cannot convert this JH into an integer over here, and this E is the description of the error. Now if I put anything outside of the try and accept block, let's say print by something like that, this will always be executed. Like this will always be executed. I put 0, 0 division error, okay, then it says by. Okay, this is executed. So this means that if I have an error over here, if I'm not even doing something like this, and I'm not using the, let's say, this variable after this one, so I can keep on with the code. Okay, so this is the use of try except block. Now let's go ahead and look at this with files. So let's say with try, let's say we have a file path is equals to, I want to say, let's open output.txt or example.txt. This one. Yeah, okay, this one, let's open this one. So file is equals to open, which one I want to open? I want to say file path in read mode as file uh, as f, and I want to say, oops, yeah, mix the syntax. Print file dot read, whatever is in the file, it will read it and print it. So in the errors, what I want to do is that I want to catch some errors. So I would want to catch file not found error. Another error that I could catch is the permission error. So let's say, so instead of doing this, I would simply print error. File not found. And then I could say accept and permission error. Let's say print error, permission not available for this file, and then I want to just keep any errors as it is. Don't want to do it. And then finally, let's see what we did over here. So we can just write something exiting the file operation. Okay, so I'll just go there and I will say Okay, so instead of let's say read, what we're going to do is that we're going to append and we're going to write and file dot write, let's say bye. Yeah, so we're not going to do this, we're just going to do this and this. And if we run the code and we say now save it, run the code. So it says, okay, file operations exited. This finally keyword will always be executed. If we go over here, we have this word bye bye over here. I just want to move it to the next line so it is easier. Now, if I give a incorrect file path, let's say I do not give a this one, no extension. So it still works. Okay, file operations exited. Okay, that's weird. Let me just quickly check the syntax. Yeah, we have permission denied, exception as e, else, okay, exception as e, error occurred. Okay, but if we do example 23.txt, save the file, run the file. Okay, let me just quickly check the syntax. Okay, yeah, because we are appending a file. So that's why it will always create a new file and it cannot run this error. So let's just read the file and let's print file.read. Yeah, that, yeah. Because I was trying to do a write operation, but instead let's just do a read operation. Run the code. It says bye bye. File operation exited by whatever it is the name over here for the example 23. This is the one that is created, which is this. Okay. Now if I say example 23 and instead of this, let's check this one. What it says is that error file not found. This error because we do not have the extension. But instead of stopping the code, it still prints this last word that is by. So for example, we want to just do some operation here in the file. We just open the file here. We just do something over here. And after this try block, we do not need the file. In case the file is not there, it will just exit based on the exceptions, and then we'll just go ahead with the print or the next piece of code. So this is how we can use this exceptions. Now you can also use these exceptions with the while loop, these sort of things with combinations. It's entirely up to you on how you want to use it based on the use case. So after this, what I want to do is that we have a project, a sort of a mini project. So what we will do is that we have the program from previous mini assignments. You can use the one that we did together or yours if it was working together, and we will try and build onto that one to get like a more real life example of how we use coding. So first you have already have a data structure to store the student data, and you can even save it now as a CSV. After the file handling, you should know how you can save it as the CSV. So what you need to do is that using the same sort of a menu, you need to add three more columns for each student, and these are the columns. This one, score math, score history, and score programming. So like they have three subjects, and you can delete the column score. You can make this one even manually. The data set in the start, like the initial data set that you have before calling the functions of add student and such that. And then you say in the same menu, let's say in the previous one where you added students, showed the information and these sort of things, you have two or three other options. You can put the options as you like based on what I'm going to describe. So you're asked to generate a report which contains some statistics of three subjects separately as well as an overall report. You have the students and you want kind of a report from these results. So for the statistics, generate one output that has the subject name, maximum score, and minimum score for each subject. Like in one CSV file, you should have score math, like the math is the name of the course subject. Then you have the maximum score in math of all the students. Then you have a minimum score in math, and then you have a average score in math. Then for history, then for programming. So this means that you would have um, three rows, one for math, one for history, one for programming, and you would have, let's say, four columns. One is the subject name, one is the highest, one is the lowest, and one is the average. And then you should also create an overall report that is like a text file. So in the text file, you just want to write a text, like one line. In one line, you would write the person who has the highest score over all the subjects. That is adding the score in all the subjects for that person. And then you will also write the name of the person with the lowest one. So you could just write a sentence: this person has the highest score. Next line, thus this person has the lowest score, and you say that okay, this is the average of all the scores of all the subjects. So this means that average of all the scores, math, science, history, and all the students. So the first one, statistics, you will save as a CSV file, and the second one you will save as a text file. And that is all. You can include this functionality in your previous code and build onto that one. So you have the previous functionality too, as well as this one. That is all for this lecture, and we will see the solution for the project for this assignment in the next lectures, in the upcoming lecture. So again, I would suggest that just go out there, Google some stuff. If you do not know, just try and put something on the table. Even if it's not too fast or not a good looking solution, that's fine. You can always build onto that one and improve that. So, and that will be the end of the lecture. And that's all for today. We will meet you in the next one. Up till then, goodbye.